Welcome to another training video by H-Impact. This is Travis Elholt, Senior Software Engineer here at H-Impact. This video will cover how to create a data repository that contains CRUD methods in our Blazor Server-side project. The data repository will implement the CRUD methods using Entity Framework Core with LINQ expressions. We'll also implement asynchronous tasks and discuss benefits of using them. Ultimately, the data repository will take advantage of the AppDbContext from the last episode by way of dependency injection to support the charts from the ChartJS JavaScript library. We are using Microsoft Visual Studio 2019 and Microsoft SQL Server Management Studio 2019 with a SQL Server Express installation. All software is free and is available on Microsoft's website for download. I have included the links in the description below. Also, if you missed the previous BlazorChartJS video, which completed the integration of Entity Framework Core for SQL data access and created a DbContext class, I've left the link in the description, as well as the project source code. Let's get started. An essential part of building applications are the operations created to manage the data. These operations are often referred to with the acronym CRUD, or Create, Read, Update, and Delete. In order to update the ChartStats database, we need to create a way to execute the CRUD operations. To do this, we need to create a repository class that contains these CRUD methods to update the cities table in our database. To begin, let's add a repositories folder. Right-click the BlazorChartJS project and choose Add. New folder, and name the folder Repositories. Great, our repositories folder has been added. Now let's add the repository class. Right-click the repositories folder, choose Add, Class, and name the class City Repo. Click Add. Nice. Now we need to access the database. To gain access to the database, we can use the AppDbContext we created in the last video. The AppDbContext has been configured within the startup.cs class as part of .NET Core's dependency injection container. Therefore, the AppDbContext within the Blazor app can be used without instantiating it inside the City Repo class and any other locations that need access to the database. Now we'll add a private read-only variable or field of type AppDbContext named _db to represent the AppDbContext created at startup. Private read-only AppDbContext _db. Nice. Now let's clear up the namespace issue we have with AppDbContext. Hover over AppDbContext, and with the light bulb, choose Using BlazorChartJS.Models. Excellent. The using namespace was added successfully. Let's highlight it and drag it to the bottom so we can keep track of the ones we add. Let's also add a using statement for Microsoft.Entity Framework Core to make asynchronous calls. We'll discuss asynchronous calls in a few. Using Microsoft.Entity Framework Core. Great. Our using statement has been added successfully. Now we need to add a constructor to the class. To do this, we type CTOR tab twice. Excellent. Now that we have a constructor, we need to add an argument of type AppDbContext and name it DB. Now let's assign the DbContext to the private field. Next, we'll add our CRUD methods. Let's start with the R in CRUD and create read methods. First, let's go after all the records in the cities table and return a collection of city objects. We'll use the IEnumerable interface as the return type. Public IEnumerable of type city, and name the method get all cities Within the method, we'll use a generic list of city objects named list_result to store the data from the database. Now let's use the AppDbContext to assign the data to list_result. _DbContext cities dbset dot toList LINQ expression of type city. The toList LINQ method expression returns an IEnumerable list of city objects. Finally, let's return the generic list of city objects. Let's add a couple of spaces to make this look a little better. Now let's use this standard method to create an asynchronous task with similar logic. Asynchronous tasks allow for processes to complete without holding up others. For example, data management operations are great uses for asynchronous tasks. The await keyword is required within the method to make the asynchronous call. Let's copy the normal version to create the asynchronous task. Great. Now, let's modify the signature to make it an asynchronous task. Async task of type IEnumerable of city, and add the suffix async to distinguish it from the normal version. Okay, and one more thing. We need to add the await keyword when we make a call to the database. Now we need the asynchronous version of the toList method. There we go. We have our first asynchronous task. Our second read method will use an ID parameter to retrieve one city from the cities table. Public city return type. Get city is going to be the method name. Integer parameter. And name it ID. Let's declare an object to store the city that we retrieve. Equals _db AppDbContext dot cities dbset dot first or default of type city with the lambda expression x dot city ID equals the ID parameter that's passed into the method. The LINQ expression, first or default, will return the object or a null. Let's check to see if the object is null first. To avoid returning a null, Let's declare a new city object here. After the if statement, let's go ahead and return the city object. Excellent. Like getAllCities, let's go ahead and create an asynchronous version of this method. We add the keywords async and task. Of type city. Now we'll add async to the name. And add the await keyword with our call to the database. We'll modify the first or default method by making it first or default async. Great. Let's add the next method, which represents the C in CRUD for create. This method will insert a new city record into the cities table and assign the ID associated with the record. Public return type city, method name insert city, city parameter, then we'll start with the AppDbContext _db .cities .add LINQ expression and pass in the city parameter from the signature. And we call the db AppDbContext again, db. Save changes. Save changes is required to commit the data to the database. Without it, your database will not be updated. Now return the city. Perfect. Just as we did before, let's copy the normal version to create the asynchronous task. We'll modify the signature again with async task of type city. I'm going to add the suffix async. And before making the database call, we're going to add the keyword await. And use the asynchronous version of save changes. Excellent. We're almost done. For the U in CRUD, we'll need to add an update method. This method will be used to update an existing city in the cities table. Return type city. Method name update city. City parameter. And it's going to be named city with changes. Now let's store the city that we need to update in a local variable. City equals db AppDbContext dot cities dbset dot first or default, lambda expression, x x.city ID equals city with changes dot city ID. Great. Now let's check to see if the city is not null before we update it. DbContext, cities, dot update LINQ expression, city with changes. Finally, we call save changes to commit our changes to the database. Now let's return the city in which we updated. Great. Now let's create the asynchronous version of this method. We need the asynchronous keyword, along with task of type city. We'll modify the method name to update city async. We'll add the await keyword here before we retrieve the city from the database. And we'll use the first or default asynchronous version of this method. Finally, we'll add the keyword await before we save the changes to the database. And we'll use the save changes asynchronous method. Excellent. Last but not least, for the D in CRUD, we'll add a delete method. This method will be used to delete a single city from the cities table. Public city return type, method name delete city, parameter integer ID, we'll start with the city object to store the city we need to delete. db.cities dbset.first or default lambda expression x.city ID equals ID. Now let's verify the city exists before we attempt to remove it. If city does not equal null, underscore db AppDbContext dot cities dbset dot remove LINQ expression city And finally, db AppDbContext.save changes will return the city. Let's create an asynchronous version of this method. We use the asynchronous keyword along with task of type city. We'll add the suffix async. We'll add the keyword here of await. And use the first to default asynchronous version of this LINQ expression. And finally, before we commit the changes to the database, we'll use the await keyword again, along with the asynchronous version of the method. Nice. That completes all the CRUD methods for our city repository class. Now let's run the app to make sure it still loads. Excellent. Our Blazor app has loaded successfully. And all the components work just fine. That's all of it. If you have any questions on implementing a data repository with this BlazorChartJS application, leave a comment below and I'll do my best on getting back to you. In the next video, we will cover creating a data service to access our SQL data that will be used in our Chart.js charts, as well as throughout the entire Blazor Server-side application. In the meantime, don't forget to subscribe to our channel and click the notification button. Give us a thumbs up with a like and share this video. Comments with or without a question are great too. Again, this is Travis L. Holt. Thank you for watching, and I hope you enjoyed this training video from HImpact.com.